This is video 2 for a property in Tullintowell for Alan Coyle. So now what I want to do here is I just want to go through for the next few pages. I want to briefly explain the difference between two different types of construction. An older form of construction, which is the solid stone wall that you're seeing here, and then the other type of construction is a type of construction where a cavity has been constructed, because they work very differently, and your building contains both of these types of construction. And a lot of the problems that your building are as a result of this older form of construction not being treated potentially the way it should be treated. So first of all, this is, up until 1940 in Ireland anyway, most buildings might have been built with a solid stone wall like this, very thick wall. And these walls were not built with cement. That's the key difference. They didn't use cement, they used a lime render, and oftentimes lime was just mixed with clay to make a very soft mortar. So the way these wall works, and one of the key differences is the stone wall will breathe. So when rain falls on it, the stone wall will soak up the water, and through the stone, because the stone is porous, and also through the mortar and the grout, it'll soak it up. When the rain stops, it'll evaporate. More moisture will just evaporate away as the wind blows. And any damp, you always have little bits of rising damp coming up from ground level. That moisture will continuously be coming up, and it will evaporate. So it will evaporate throughout the front wall. Generally not so much through the internal wall, because you'll have more wind movement out here. So most of it should go to the external wall. So in short, it's a breathing wall where moisture that comes in will dry out through evaporation. Now, I'll also point out here that, oftentimes let's say there's just flagstones or paving stones that were put down internally, and water vapor would just evaporate through those stones as well. Now, if we come on to a more modern building, so since about 1950, 1960s in Ireland anyway, in the west of Ireland, most modern buildings work on a completely different principle. They don't breathe in the same way that an old stone building breathes. What they do is they attempt to prevent moisture coming into the building completely. And the way they do this is, let's say you see this dark black line here. This dark black line here is called a damp-proof membrane, or a DPM, and it's really just a thick plastic sheet. And any dampness that's in the ground that will come up through the ground is stopped by this damp-proof membrane. So it's a complete barrier at the floor, so you'll get no rising damp coming up through the internal leaf of the wall, and you'll get no rising damp coming up through the floor. The other thing that you'll have is you have a damp-proof course, a DPC here, a damp-proof course on the external wall. Now the external wall here is shown as brick, but it could just as easily be concrete blocks, the same as the internal. And that would prevent rise. That's just basically, it's a plastic membrane as well. It's just a slightly different type of a plastic membrane. And again, it's to stop rising damp. Now, the other thing that you have is you have a cavity. So you have, generally what you have is a 100mm cavity, or a 4-inch cavity between the internal leaf and the external leaf. Sometimes this is partially filled with insulation that's fixed to the inside face. But basically what happens is any rain that hits the wall, it can soak through to the cavity. But at the cavity, it can't soak any further, and any moisture that gathers will just fall down the inside of the wall, and it will be pushed back out here due to the fact that the internal floor is higher than the external floor. So you have a complete barrier the whole way around, which stops moisture coming in. And this system probably works slightly better than the older system, because sometimes you can get slight damp problems with the old system. But the old system does work and can work very well if it is if it's understood how the old building system works, and if the way it works is understood and respected, and it's treated carefully and well, you can have very, very minor problems with dampness that really won't cause any problems at all. However, what happens is you can have old stone buildings that were designed to breathe and let rising damp evaporate, not work the way they were supposed to work, because what happens, people often put on a cement render externally. And this is what's happened in your building. This kind of remedial detail that is often done, very commonly done to old stone walls, traps moisture in the walls and can cause dampness. And this has been done on your building. There are ways to help treat it, but it's something that's happening, so you need to know that it's happening. The first problem that's happened is, and I suppose probably the most significant problem, in the 1950s, I suppose, in the advent of cementitious render, a lot of people put a cement render, and you can see here impermeable cement render, put an impermeable cement render on the external face of the wall. Now, it's okay to put a lime render, but not a cement render. And it's okay to put a lime render because lime breathes. But cement is very, very different. I mean, cement is stronger. That's why when it came commonplace in the 1950s, a lot of people used it because it was stronger. But it causes problems in that the stone walls that were traditionally breathing couldn't breathe the same way because they had an impermeable cement render on the outside. Now, this impermeable cement render, it can stop rain from coming in, but it also has the negative effect of any rising damp coming in, it can't evaporate because this cement render is impermeable. And oftentimes, I think the cement renders were added because it's what was available in the shop, and that's just builders got used to using it without realizing that they were causing problems with dampness being trapped in the wall. So basically what can happen is the rising damp is coming up, the cement render stops it from evaporating, and then what happens is it can't go out, so it goes the only way it can, and it goes to the inside of the building, and you often find rising dampness and mold growth here. And then what happens is people sometimes try to tank it from the inside to stop the dampness coming through, and then sometimes what happens is dampness will just go further up the wall. Or what can happen is the dampness can sort of push the tanking off. Over time it can start to delaminate and push it off. One thing that exacerbates the problem is, when old buildings are renovated, what happens is these concrete slab is put in with a damp-proof membrane. And the damp-proof membrane does stop dampness coming up through the floor slab, but you can't really put in a damp-proof membrane here in the existing wall. So all of the moisture that would have come up through the floor is now coming up through the wall. And another problem that can happen with the addition of a cement render is cement render will, let's say, after a certain amount of time, the cement render is very hard and cracks can form in the cement render if it's not maintained. If the cracks are not filled and it's not regularly painted, what can happen is cracks can form in the cement render. And basically what will happen when rain hits that wall, rainwater will be sucked in, will be pulled in to the wall, because the wall should be relatively dry. So I always equate it to like having a hole in your shoe and your sock gets very wet very quickly. Rainwater will be pulled in through cracks if the building is not maintained. And then what can happen is, because the cement render is not permeable, when the wind blows, the moisture can't evaporate. So the wall is constantly wet, which can lead to degradation of the mortar and the wall. So if you are going to keep the cement render, you have to maintain it, make sure that there's no cracks in it, and that it's well maintained and painted. And even if it's well maintained, it may still cause problems with rising damp. Now, there are methods of relieving these problems, and I point this out because you have some of these problems with your property. So I'm just going to go through, before I get into the specifics of your property, I'm going to talk about some of the standard methods of dealing with moisture and some of the best ways of dealing with moisture. And there's really 3 ways of dealing with it. Now, the first thing I want to point out, the first probably the thing that happens to cause dampness, rising damp, is over time the external ground level is built up, or it may have been constructed with the external ground level being very high. Now, this particular wall here is shown as a brick wall, but this could equally apply to a stone wall. It's the point to note is that this is a solid wall. There's no cavity and there's no barrier. So if you build up the external ground level to the point where it's higher than the internal floor level, dampness can just penetrate through very easily, lateral penetrating damp at low level, and you can start to see mold growth and problems here. And this is one of the first of the 3 ways of relieving the problem that I'm going to discuss. This is probably the first and the easiest method of relieving the problem, would be to reduce the external ground level, to try and get it to at least 6 inches or 150 millimeters below the internal floor level, to stop this easy passage of water. Now, if you come back here, if I go back here to, this is the first drawing I've shown you. Now, this is an example of a stone wall that's working the way it's supposed to. And you can see here the external ground level is actually 150 millimeters lower, or at least that, than the internal floor level, and it works well. Now, the other thing that I should have pointed out, I forgot to point out, I did point out that the addition of a cement render on a wall that's supposed to breathe can trap moisture. It can prevent rain coming in, but it also traps rising damp from getting out. And overall, it causes a problem. And that's the addition of the cement render on the wall. But equally, the addition of a concrete footpath here at the external of a building, that can also cause problems for an older stone building, because any dampness that's coming up that used to be able to evaporate cannot now evaporate, so it goes up the wall. Now, you might say to me, okay, yeah, but it stops rainwater from seeping down through into the ground and it helps it to flow away faster. Yes, it does. It can do that. But it also stops, when the rain stops, it also stops the ground from drying out and evaporating. And the ground will always be slightly moist, even though it may look dry because you have a concrete footpath. In general, you don't provide, or providing a cementitious footpath in front of an old stone building like this can cause problems, in the same way that providing a cement barrier here causes problems. It's the exact same principle here. Now, on a more modern building where you have a membrane here and a cavity and a membrane here, providing a concrete footpath here is no problem at all. When you have a concrete footpath here, that does not cause problems because you have barriers to stop the moisture coming in. But providing that on a stone building, on an old stone building, causes problems. And again, you have that with your building. So that was the first. The first problem is, let's say, an external ground level that's too high, that can be lowered to stop penetrating damp. The next thing that will help alleviate a problem, if a problem exists, is the provision of a French drain around the perimeter of the building, which will effectively remove the moisture from the ground before it has a chance to get inside the building. So there will be basically a French drain or a pipe in this trench here that will be draining somewhere to a watercourse somewhere, which will take away any water that falls. So any rainwater that falls will go straight down into this downpipe, and it'll get away. Now you might say, well, hang on a minute, surely having rainwater falling down the wall and coming into the ground here will sort of saturate the ground. But it doesn't really work like that. Basically what happens is the water will go down into the drain, and if it drains well, it'll get away. But as soon as the rain stops, the moisture will evaporate. And overall, this works better. A perimeter drain works better than having a concrete footpath. Now this is a cross section through the perimeter drain here, which can effectively lower the moisture or lower the water table to stop dampness coming in. And now, so basically that's the second option. That's the second way of alleviating a problem, providing a French drain. And this is a much more preferred way of dealing with the problem, stopping the water getting near the wall in the first place, rather than trying to tank it from the inside after the wall has already become saturated. So you try and stop the water from coming near the building rather than trying to tank it from here, because this is a much better method. And this is the second method of alleviating the problem. So I've talked about lowering the level, this now providing a French drain, both relatively simple methods. The third way that you can alleviate the problem is to replace the cement render on the building with a lime render, a render that breathes. Now that's a more expensive method. You could imagine taking off the cement render here is a big job. It may not come off that easily, depending on how well it's done. And what I always recommend is try steps 1 and steps 2 first. Try lowering the external ground level and putting in a French drain, and see if that kind of resolves the problem enough. If it doesn't resolve the problem to your satisfaction, then you might consider replacing the cement render with a lime render. Now, so what I will say is if the cement render is going to be maintained, the cement render, or if it's going to be kept, the cement render must be maintained in a good condition. As in, if there are any cracks that form in the cement render, they must be filled straight away so that rainwater cannot penetrate. Because as I say, if it does penetrate, the cement render will stop it from evaporating and drying out. Okay, I'm going to stop this video here because that's just a summary of the typical problems that you get with this type of construction. And if you look at it here, this one here is, that's the plan. That's the plan of what's existing. So you have your old stone wall here, your old stone wall, and then you have your extension here, which is a cavity wall. Two very different types of construction. Both can work very well if they're treated the right way. This one is working very well. Your extension with the more modern construction is working very well at the minute. The stone is working okay, but it could be working better. And if you want to try and get improvements in the future, you know, those two methods that I discussed will help achieve some improvement. And I'm going to stop this video here now because it's gotten too long, and I'll continue on in the next one.